All right. Good afternoon, everybody. Welcome to FOP class six. Yeah, six. Thank you guys for being here. I hope you guys had a great day. Yesterday, we finished off the class talking about the to-do list um, and CRUD applications in general. We started off the assignment, but we really didn't get too far on it, or honestly had much time to do it. So today, the first hour, maybe less, will consist of actually going through the to-do application, giving you guys the allocated time, um, and talking about it. Um, Before we start, and break you guys off so you guys can go and work on the assignment itself. Did anyone attempt it last night or have any questions in regards to the assignments that you guys want to address before we split up?
I was doing it last night. I like it.
Okay.
I like it's doing now for right now, and I'm doing it the long way, meaning that the same way that I would write it out in the if I was actually writing it, that's how I'm doing each step individually. Like if that makes sense.
Uh-huh.
Oh yeah.
Jonathan Taylor. Yes, I do apologize for that. I literally just woke up. I've been asleep all day. My fault. Um, but the video itself, there wasn't really too much to talk about. You can honestly just check out the CRUD apps lesson 6, and it'll talk to you about CRUD. Essentially, it's just how applications can create different things, read, update, and delete. Reading be displaying the text on your browser, right, and showing you you're visually able to read what the application is showing you. Uh, Creating stuff like creating an account, creating a user, how it when you create a post on your Facebook, these are capabilities of different applications. Updating your status, updating your profile information. Applications allow you to do this, right? And then as well as delete, right? The D in CRUD, being able to delete stuff. Um, and what we're doing for the to-do list is essentially replicating these capabilities from this CRUD application, right? Being able to create some type of application that can create something, read, right? Display to you the information, update, and delete. Uh, so that's kind of like the main gist of CRUD, and that's what this to-do list allows you to work on. So you can open up the lesson and it'll show you an explanation of it and what the to-do list should look like. But for the most part, it was a lot of individual work, so no stress. I'm going to be uploading the YouTube video in a bit. Um, I do apologize for that. It won't happen again, I promise. Uh, but yeah, and Mike, good stuff. I did stay behind to talk to some people after we closed off the class yesterday. Hopefully, I was able to answer any questions for you guys. Um, Anybody else? No one has any questions at all? It's fine by me.
Yeah, would you like me to, would anybody like me to tag along for any of the work you guys are doing?
This is Brandon, guys. He's been a little MIA due to college requirements, but he is back now. We can break off into, let's say, I'll break you guys off into individual teams since Brandon's here, so he can help me. Um, we'll go off into individual teams, and then Brandon and I we will bounce off between the different teams, and we can provide some one-on-one mentorship, I guess, or answer any question you guys might have. How does that sound? You guys good with that? Okay. Yeah, we'll leave it at that. I'll break you guys into some breakout rooms, and then you guys can ask any questions you guys have there. Uh, and yeah, let me go ahead and pause the recording. Let's
Yes,
go
I
ahead. Awesome. Let's go ahead and come back from our break. Let's come back to our cameras. Mike, if you don't mind muting your mic, I can hear myself. That'd be appreciated. Thank you, brother. We're gonna go ahead and cover the to-do list assignment, and we're gonna go and code along as well. So let me go ahead and pop this bad boy open. Let me delete some of this code. Okay. Can you guys see my screen or like no?
Not yet. We just see you.
Awesome. Okay, here we go. This is gonna be my to-do list, walkthrough. So as you see here, we have no JavaScript within our assignment. I have some HTML in here, right? I have a couple things. I have my header just so I can ensure, you have the to-do list in here. I got a div that's holding everything within it. So I just call it like my root list. This is what's gonna hold the input area as well as the actual list itself with its list items. The next div is the input area where we receive the user input as well as a button. And then I have a div where my list items are going to go. I created the unordered list, but it has nothing yet. So let's go into our JavaScript. And by looking at my to-do list, right? So when you guys got the assignment, you have to think about a couple things. Well, first and foremost, we need to receive user input. All right, so the user should be able to come here, add something inside this input text, whether it's gonna be clean, cook, do laundry, whatever the task may be. We want to be able to grab that input the user's given us and then display it on our screen as a list item, right? And just to make sure that this button is working and doing its thing, and we connected our JavaScript the correct way. I saw you guys talking about the JavaScript. You can do it, on the head, or you can do it at the very bottom of your HTML. We're just gonna go ahead and test out this button to make sure that our script is actually linked. You would be surprised how many of you guys are, the only issue was, and it's not just you, Kim. I'm telling you, not just you. The issue was how we linked the script, right? So first and foremost, it's probably important to ensure before we start breaking our monitors is to ensure that it's working. So we're gonna grab that button using the query selector. I call that button. I gave it a class of add task. And then we're gonna add an event listener on click. And then it's supposed to have a function here. We'll call it add task for now, right? Add task, and let's go ahead and create that function, add task. And all that function is gonna do, it's gonna be to console.log connected, right? So if my JavaScript is working, it should be able to print connected, which it is. So I know for one, my JavaScript is working and we got that button to do something, right? And that's a start. That makes me know, or lets me know, that our JavaScript is good to go and we can move forward. So the name of this function wasn't just made by mistake, right? This should be adding a task. And when we receive input, it should be given within here. Oh, what can I type? There we go. It should be able to put input in here. We should be able to receive it and save it into a variable. So to grab that input, I know that I want to be able to press this button and grab the stuff within this input tag. So let's look at the input tag that we created. And notice that I added a placeholder called task so they know what to put in here. And I called it user input. So I should be able to do something like let new task is equal to document dot query selector, right? And I'm trying to grab the user input. And for the user input, I want it to value, right? So this method right here specifically should return to me the value that's going that this input tag would have, and then save it to the variable called new task. And now it allows us to do something with it. Once again, I do this every step of the way to show you guys, it's sometimes, it's okay to just ensure that your button or your code is doing what it should be doing. Because there's no point in adding 20, 30 lines of code if, there's like 3 errors in there and now you don't know where it's at. Now it's just more debugging. So just make sure it's working as you guys go through it, and as you're slowly learning, and as you guys get better, you come to realize that you won't have to do it as often. But it's always just good practice just to make sure that what your code is doing, you should be doing what it can if you're able to console log it or just visualize what your code is doing. All right. So it's working. I had it clean, it printed it out. So that value is in there. Now, once I get that, I want to do something with it, right? I want to create a list item. I'm gonna take the info that user gave me, and I want to create a new list item and then add it into my unordered list here, right? So we talked about it yesterday about creating new elements. And we're gonna go ahead and create one here. We're gonna call this let new list item is equal to document dot create. I want to say element. Check my notes here. Create element. And then within here, it should just take the tag itself of what element you're trying to create. So it should be an li, right? A list item. So this is going to create that list item for me. And it's not going to have anything. It's not going to have any kind of text in it. It's not going to have any styling. It has nothing special, but it's just an empty list tag, right? And then after that, I want to manipulate that tag. I actually want to change what that tag's gonna have. We already have the input the user is giving us, right? It's clean. Now I want to add that to my list tag. So we can do new list item and then do dot inner text and change it by adding the new task into it, right? And that creates my list item. I should be able to print this out. I wonder if I can. I don't know if it'll work. Clean. I don't know what it showed me in my console. Oh, dang, it does. Look at that. It constantly logs the tag itself and what text I added within it. So I console.log the new list item after I added the inner text. And we see here in the console, it created that list tag, right? And it added the actual text in it. So I know it's working. But it's still not displaying on our browser. And that's because we haven't manipulated our DOM yet to show it and to put it here within our unordered list, right? So next part is going to be manipulating the unordered list. So notice it has a class of list, and I'm going to want to add something to it. I'm going to want to do what we call append a child, right? We're forcing the life of a mother and father onto this tag. We're going to give it a child regardless, right? So we have that method, which is append child. So let's go back to our JavaScript. We're going to go ahead and do, let's actually grab that first. So document dot query selector. It was list, right? So we're going to grab it. Then we want to do append child, right? So we grab it and then give it the child that we created, which was that new list item. And literally, it should just be a new list item. Just pass it straight in there, right? That should add that to our browser. So let's check that out. So we can go ahead and do clean, add task, and there you go. It adds it to our list, right? It gives it a child and displays it on our browser. Cool. Did most of you guys get up to this part in your code? Awesome. Anyone did not or have any questions up to this point before I move any further? Okay. All right, cool. So we got the first step down. Now, let's get rid of this new list item console log. We don't need anymore. We have that clean that task within our list. So we're making progress. We're actually updating that list. We're creating stuff, right? So we're putting stuff onto our list. We're reading it. But it's not complete yet, right? There's something missing here. If we recall from the to-do list.jpg, it should have some way of deleting it. We don't have a button yet. We can add that very quickly. So similar to how we created that element li, right, for list item, we can create a delete button, right? So let delete button equals document.create element, right? And we're gonna create a button at the same area that we created that list item. We create that button, right? All this is being done at the same time, right? At the same time we create that list item, we can create that button at the same time. Just do it all at once. We can create that delete button. Could we separate this? Yes, we could, but I'm just for the sake of time, we can just do it here. All right, so I'll leave that separate so you guys can see. So that's where we create our button. And now let's manipulate that button. We could do delete button dot inner text, I believe is what it should be. Or actually inner HTML. We'll see. And just call it delete. Let's check that out. Oh, it's not gonna show, right? Why is it not showing? Well, because we haven't added it to anything. All right, so we created, but we haven't added it to anything. So where should we add this? Would it make sense to add it to the list item or the list?
I think each item needs to have its own delete button.
Yeah, each item should have its own delete button. So where should we do that in our code? Well, it doesn't make sense to add it to the list item after we already appended the list item into the list. Because if we add the list item first before it has a button on it, it won't have the button here. So somewhere before we add the new list item into our list, we should do document dot query selector. Actually, we don't even have to do query selector. We should be able to just do new list item. And then dot append child. And give this bad boy our delete button. Right? So we give that delete button to our list item, and then we add our list item into our list. And go up here, type in clean, and there you go. Our list item has that delete button embedded into it. Right? Okay. So far, so good. We have our list item. It has a button. Now let's see, what if we do cook? It should have the same thing. There we go, cook with the delete button. Later on, we could change the styling of the delete button. We can change it to an image. It could be a trash can. We can remove the text itself. It does not matter. Point is, we have a button here that's supposed to delete, right? Doesn't have to look exactly like the picture, but we're on the right track here. So awesome. We're creating stuff, we're reading it, but we're not able to update anything, and we're not able to actually delete anything. So that's going to be the next part of this, right? So let's go ahead and update. We'll work on the updating of this task. And what I want to do is essentially, if we look at the assignment, right? It should be able to have a strike through, right? The assignment wants us to update the list item by being able to click it and strike it through, letting us know, hey, we've completed out, we scratched it out of our to-do list. Right, that should be the update. Some of you guys probably went a different manner of it, maybe adding like a checkbox, and delete, pressing the checkbox and deleting it, or we might have a button or checkbox that when you click it, it lets you edit it. That's a way too. You guys can try different things out. We're doing it like the assignment. So we're gonna go ahead and do something about this strike through. So what is that little strike through that we see here? Well, in short, it's pretty much just styling, right? It is just styling. But we need to create a function that whenever we click it, right, on the click, it edits its styling. So before we go ahead and append that list item to our list, it should already have that function built into it, right? It would make it more difficult afterwards because we have to go through every single one and then change it. So right now, once it's born, right, we immediately give it that ability to style, right? It's one of its uh amendment rights, you know, the ability to strike through. So we're gonna go ahead and do that upon appending the child. And the way we're gonna go ahead and do that is by we create the element here. So here, on line 6, we're gonna go ahead and add an event listener, right? We're add the event listener before we even add it into our list. So we can do, actually, let's do it in its own separate area. So we create elements there. We can do new list item dot add event listener, right? So after it gets created, we can add the event into it. And then within here, the event will be a click, and the actual function itself, we can call it update. Right? We just call it update. Well, this method doesn't exist yet anymore, or yet, right? It doesn't know what update is. So we can create that method up here. We can do function update. I really dislike how let's look at. We create function update, and then what we're going to do is we're going to check if whatever element is calling the update method. We're going to check, hey, is this element already strike through? If so, then undo it. If it isn't strike through, then strike through. So essentially, we'll need an if-else statement that's going to check the styling of our actual element. So we're going to do if this, right? So remember, this is the third time we use this here on our examples. Whatever is calling this function, that's who this is, right? It's referring to the person calling it, right? The element calling it. So this dot style dot decoration. All right, so this is a method you can look up yourself. How to change the style on your elements, just like there's different ways of adding inner text, HTML, create elements. That's just another method that you guys can use from the DOM, right? So the style dot decoration, that's where that's coming from. Like I found that on W2 Schools. You guys can look it up. So where, like Roger, are you pulling this out of thin air? No, I'm not. All right, so you can look this up. So if this dot style decoration is equal to, and we're going to check if it's equal to line through, right? So this is the styling for the font formatting of the line through. So if this dot style decoration is equal to line through, then what we're going to do is change the style to none, right? That means if it's already been scratched off, but you want to, update again, hey, you know what? Turns out I updated the wrong one. I got to undo the scratch. Then we're going to change it back to none. Else, this dot style dot decoration is equal to line through, right? Pretty straightforward. It's just an if else statement checking what's the status of its style, whether it's been scratched off or not. So this function is declared. We pass that function into our new list item. And now, if we did this correctly, we should be able to do clean, add task, then on the click. Oh no, we did not do this true. Okay, what did we do? We did not do this correctly. I wonder why. update void. Update, maybe because it's called update. I don't think it would make a difference. Does anyone see anything I don't see?
Roger, I put my function into the code I found out just before we jumped into this. I did this dot style dot text decoration.
Text decoration.
Yeah.
Yes, that's what I'm missing. Okay, thank you. I thought I was going crazy. Text decoration. I just learned this this method, so don't hang me for it. But text decoration. All right. That's what it probably is. I'm pretty sure it's with the. Let's check that out. Clean. There we go. Dang, dude. I knew something small, right? It's always something small. It's a type error or a quotation mark, whatever. So there you go. So we are updating the clean. It did what we wanted to do. We can scratch it off if we complete it. Hey, I messed up. Let me go ahead and undo that. Pretty straightforward, right? We added that method when we created it prior to adding it to the list item. All right, that's important. Prior to adding it onto the list as a list item, right? We're doing this all as we're creating it. Once it gets appended to something, you're gonna append it in the stage that it was. All right, so in whatever state that list item was, that's where it's gonna stay. Okay, so so far we're creating elements, we're reading them, we've updated them, but last but not least, we can't delete anything just yet. All right, so let's go ahead and do the delete method for that. Very similar to how we added an event listener for our list item, we're gonna do something very similar to that for our delete button. So I want to move this to the bottom. I'm just a little OCD about some stuff. All right, so we create the list item and the button. We change the inner texts for both of them. We add an event listener for the new list item, but now let's add an event listener for the delete button. All right, so delete button dot add event listener. Do click, and we're gonna create a method called delete task. All right, this method still does not exist. All right, so up here we're gonna do function delete task. And then what we're gonna do, we need to delete that list task completely, right? And what's cool is if you kill the parent, you kill his entire bloodline, right? So by removing the parent, we remove the button as well. So what we're gonna do is we're gonna call the parent by using a method called parent node, right? So we're gonna do let parent node. I'm just calling it parent node. This is the method we're gonna use. We're gonna use the this dot parent node method, right? Actually, let's change the variable so you guys don't get confused. We're trying to grab the parent of whatever it is for the button. So whoever is a parent for the button, that's who we're trying to grab, and we want to remove that parent out of the picture. That way, it removes it off our list. Because if you guys recall, where do we add the button to? The button was appended to the list item. Therefore, the button is a child of that list item. So when we click that button, right, the delete button, it's going to run the delete task. It's going to check who this is, or the tag that's calling this function is the delete button. So it's going to be delete button, and then it's doing dot parent node. So it's grabbing the parent of the delete button, and it's assigning it to our variable called parent. All right, parent being the list item itself. And then once we have the list item and we've grabbed it, all we have to do is parent dot remove. Right? So if we go up to here, we do clean, add task. We can update our clean, and then we can also delete it off of our list. And we successfully completed this assignment. We were able to create different elements, right? Whether it's a list item, a button, right? We were able to update it. We can read it, right? It's on our browser. It displays to us our information. And then we're able to delete it effectively off of our entire list, right? Essentially, it was, no more than probably 25 lines of code, 20 codes, 20 lines of code. Cool. I will now open up the floor for any questions that you guys might have. Nothing at all. So you guys get it.
I took a walkthrough with a few people, and they were definitely on the right path. So
Okay. That's good, right? That's good. I don't need you guys to be subject matter experts right now. Would it be cool? Sure, right? But that's not what's really expected from any of you guys. So as long as you are understanding the concepts and you're making progress and you're on the right path to get into this point, then that's all we need from you guys. All right. Continuous improvement. And honestly, just giving a damn, right? Giving a damn enough to actually putting time into it, kind of asking questions, making the mistakes, having to debug the issues, and just trying to figure out what a solution, what the solution is. And that's good, right? But we're going to go ahead and move forward. We spent way too much time on this already. I just want to make sure that I believe this is the last one that we have to do for with any real JavaScript, actually, I think. So after this, we're closing this chapter. All right, so that should conclude our to-do list, right? We built a replica of the to-do list. It doesn't look like this. All right, I'm not going to spend time on the CSS. You guys are more than welcome to if you want a nice little exercise of CSS, but not really needed, right? We're going to go ahead and move forward with our lesson because that's the end of lesson 6. And if we go into our schedule, we are slightly ahead of schedule, but we are going to start today the Python crash course. So you guys can open up the slides if you guys want to follow through. We are going to start working with Python. So up to this point, a large majority of you start off with JavaScript. You probably went through the intro to coding. Some of you guys attended a quick pass, and all you know is JavaScript. We are going to touch up a little bit on Python and kind of get you started, right? Introduce you to the syntax, and kind of start thinking about switching between both of them. So it's not brand new when you guys get into the immersive program. Because Brandon, you can correct me if I'm wrong. It should still be the object-oriented programming pretty early into the program itself, and you start off with Python, and then I think the first week is like the basis of Python, and then the second week is pretty heavy on object-oriented programming, and then you're given an assessment, right? So it's good now to start looking at Python if you've never seen it, and that's what today's lesson is going to be about, right? This is going to be lesson 7, Python crash course. This is probably a good time to open up your Anki decks if you have them. If you write notes, all right, this is probably the time to kind of make those quick notes about what the syntax is, and how to write stuff like how to declare a variable, right, or how to write if-else loops. I'm sorry, if-else statements or for loops on Python, right? So if you think syntax is one of the things that you struggle with the most, even if JavaScript is the only language you know and you're still struggling with that, it's probably a good idea to do that for Python as well, right? So kind of get those notes ready so you're able to practice that and know the difference between them. All right. If you guys recall that conversation we had about objects in JavaScript, right? How there's like callable objects and literal objects, and how like Python calls it dictionaries, and then they actually call it, their objects like classes, right? Or how they're built is called classes. So there's some differences there, and it would help. Computer science. So computer science is big, and it's more than just programming computers. If you guys are in college for a CS degree, if you're taking a CS degree, it's a large combination of all these, especially if you look at what the degree plans these days look like. They're even adding some AI into it. Bioinformatics, cryptography, a little cryptography. English is my second language. Networking, security, robotics, AI, and many more, right? That goes into what computer science can be. So it's such a very broad spectrum. What links all these together is a pattern of algorithm on how to transform information, right? Computer science translates to the science of information in many languages. We learn programming languages so we can express our algorithms. We will learn Python this week, but it's not about the language. It's about the ability to think algorithmically, whatever, dude. Moving on. All right, so what is an algorithm? A pattern for how to manipulate and transform information, right? We call it patterns sometimes because it must work for all cases of the problem and not just one specific case. For those of you who have been doing leak code, who've been doing code wars, you spend 20 minutes, creating this awesome algorithm and you pass the first test just to find out there's 73 other tests that you are failing. And you're like, what the heck, and that's because you failed to take into account like what happens if the array is empty, right? If the array has a million different items in it, right? If there's zeros in there, so pattern because it must work for all cases of the problem and not just one specific case. You think you're solving the issue, he's come to find out that people are assholes and they're always find a way to break your code. All right, so a step-by-step set of instructions for accomplishing some task. That's what an algorithm is. What is a computer program? It's a set of instructions, right? An algorithm that expresses some specific computer language. We'll be writing our algorithm or instructions in Python this week. So running Python locally, at this point, if you guys have been running your code in your terminal, you'd probably be using Node for JavaScript. To run Python, the default tends to be Python 3, right? So I believe the install office has you guys download Python. Am I correct? All right. I haven't done it in a while. So you guys should all have Python. If not, download Python 3. Typically, you want to type in Python 3 and then the name of the file you want to run on your console. If you did the install fest, you should have the alias for it, which is Python. You can check if you have it downloaded by typing the following in your terminal: Python -- version, and it'll show you what version you have. And once again, this is how you execute a file. If you don't have the alias for Python, that's okay. Just put Python 3. It's not a big deal. Just add the extra number, right? It's just convenience, but it's not a deal breaker. It won't ruin your whole day. Right. So follow along exercises. All right, as we go through this is gonna be very, very beginner, right? If you started with Python and you were learning JavaScript early, this is gonna feel like very soft to you. But for those of you that just started JavaScript, like I have to be very deliberate with it. We're gonna go ahead and go super slow with this and just kind of get used to it. Let me go ahead and open up something here so we can kind of code along. File Python code. All right, cool. Can I zoom in here? Oh no, what happened? All right. So code along, right? So this is gonna be you guys are gonna be go ahead code along with me. If you need me to slow down or you have any questions, just go ahead and ask, stop me in my tracks before I move on. The first thing, that you guys might notice is how to declare variables. So up to this point, you guys have been doing stuff like let, right? You've been doing const. Some of you weirdos still use bar, right? For Python, it should be as simple as just declaring like, name is equal to Gary, right? You don't have to tell it what the heck name is, right? Just go ahead and type that bad boy in there, right? So first difference from Python JavaScript, how you declare variables differs completely. We're gonna go ahead and talk about user input. How do we collect user input using Python? And that's one of it's actually the first thing I learned when I started coding Python. If you guys follow around with the Python crash course, they teach you that. I think Gary has a book. But they show you how to receive user input from the user and kind of create like a little guessing game. It's a very common like beginner.
Is this
Yes?
the JavaScript equivalent of prompt?
Yes. It is the JavaScript equivalent of prompt, right? So we see here, we create a variable, and that variable is called favorite animal, right? And what they do is they use a method called input. Input is a method that's going to prompt the user for information, right? On the console, it's going to prompt you for something to type in, right? And whatever that user gives back into the console is what's going to be saved into this variable. Within the opening and close parentheses, you're able to give it a text, right? Which is going to give to the user, right? It's what's going to be displayed to them, followed by their like a line telling them, hey, say something to me, right? And we'll see that. So within input, what message do you want to ask the user? Was please. You guys can actually, let's go ahead. You guys can just go code along on your computer. If you want to see the slides, you guys can see the slides. Open those slides for you guys. But I'm going to go ahead and just kind of open up my whole VS Code so I can code along. Within the input, we're going to use please enter your favorite animal, right? A colon and then space. And then what happens is when you run this, it's going to prompt you. If you see your console here, it says, please enter your favorite animal. And then there's like a little bar here. That's where you're able to type in your answer back to the command. Whatever you give this command, it's going to be saved into the variable favorite animal. I put animala. So dumb. All right. They just say tiger, right? It doesn't say anything back to us. But let's go ahead and change that. We can do, we're going to go ahead and print something out on our console. And up to this point, you guys have probably been using, hi buddy, that is busy. Can you go over there one more? Bye. So up to this point in JavaScript, you'll be doing console.log. That's always seemed so weird to me. I don't know why it's used console.log, whatever. Since I started Python, this made more sense. But to print something on your console, you're gonna use the word print, right? Very English friendly, just print, open and close parentheses, and you can print whatever you want here. We'll use hello as an example right now. We're still being prompted for input. We'll give tiger, and then on line 3, we're printing hello, right? So instead of console.log, it's a little bit more human. It's gonna directly just use print to actually print out whatever you want on your console, right? I guess console.log makes sense, but print is a lot more user-friendly, especially if you've never seen code before. It can seem a little intimidating when you have things like console.log. Like, I don't know what a console is, right? So print is very beginner-friendly. But within the print, we're going to change this up. And we're going to give it, what we're going to say is going to be kind of like some string interpolation, right? So we're going to go ahead and do your favorite animal is the, and then notice we're going to leave that empty. We're going to close out the quotation marks. We're going to do a space, do a plus. We're going to concatenate the string with the variable we created. So your favorite animal is the space, and then we go ahead and close it off, plus favorite animal. And then we're gonna do another plus sign, and we're gonna add a period, right? So we can format a cute little sentence here, right? Nothing crazy. Let's go ahead and run that code. Please enter your favorite animal, capybara. And then we see here the print. Your favorite animal is the capybara, right? So, how do we prompt the user for input? Using the input method, right? Within the method itself, you can give it a message. So you can prompt for the user to let them know what kind of input they need to give you. That gets saved into this variable called favorite animal, which we didn't need to use let or const or var to declare. And then we printed out something in our console using the print method and concatenated this string with the variable. Right? Pretty straightforward. Moving on. Floats and exercises, right? I'm sorry, floats and ints. What am I saying? I'm stupid. Floats in integers, right? So next is gonna be floats in integers. So to declare a float, if you guys know what a float is, it is a decimal, right? So floats is what we call our decimal points. And to declare that, you're gonna have to use the float method. So we're gonna go ahead and do a variable call here. We'll call it decimal, right? And then we're gonna assign it to a float, open and close parentheses, and then pass in a 5 here. What does that return to us? I'm done. I'm not printing anything out. Print decimal. Right, 5.0. So it takes this number 5, and then we wrap it around this float, right? Therefore, converting it into a decimal, and it prints out a decimal for us. And then we can do the exact same thing for not a decimal. How do we convert something to an integer? We use the int and then pass in the 5. This is one of the things I love about Python. For JavaScript to convert it like a string into an integer, you have to like parse int. For Python, it's just like int. You know, it's so much simple. Very, very straightforward. Doesn't have to give you these weird commands. We can print decimal and not a decimal. All right, and see what that returns to us. We see 5.0 and then 5. Cool. And just like before, it is saved into a variable, so we can do something like this. This is a decimal, and then do some string concatenation. Bring in this variable here that holds decimal, and we'll see that print out. This is a decimal. What am I doing? Can only concatenate string, not float. Oh, my bad. We should be able to wrap this in a. Oh, I see what it did. We could wrap this into a string, but we'll do it that way. This is a decimal. They print it out as 2 different variables, essentially, like 2 different parameters. All right, so they print out the first one as a string with space, and then they print out the decimal. Actually, we don't even need a space because it will naturally give it a space since it's 2 different parameters that are being passed here. This is a decimal 5.0, right? And then we can do the same thing for not a decimal. Print. This is not a decimal, and then not decimal. Once again, I know this might be like super slow for some of you guys if you're familiar with Python, but I have to go this slow for our non-Python users, just to ensure that we don't lose anybody. And if I'm being honest with you, a lot of you guys might not retain this right off the bat. It's gonna take practice, right? Just like you start off with JavaScript and you're like here and there, you might forget some of the syntax here, how to use a method or how to use a dictionary, or in what we call in JavaScript the object. It's same thing here. It's gonna take some practice, right? So it's important that even it's very simple, code along with me, right? Code along with me. Ensure you guys get that muscle memory practice in. So that's our floats in our integers. Next, which is you kind of just saw a small representation of that of concatenating strings, but next would be strings and concatenate, right? So for JavaScript, how we did it, some string interpolation, we essentially used the backticks, right? The backticks immediately just let the console know we were mixing in some variables within our strings, right? For Python, it's slightly different. This is a little different. Not the most user-friendly thing as JavaScript was, but it's a little bit different. So we're gonna create a normal string here. We call it normal, and this variable will have this string is, and then we can do fancy. We'll create a variable called fancy, pass in the string fancy. And there's two ways we can concatenate our strings. As you guys already saw earlier, we can do we can call a variable, right, which holds a string, and you can do a plus sign. We can assign it an empty string using the quotation marks, right? Do another plus sign and then assign it another variable. So this is concatenating using the plus signs, right? And then we can also do it in this manner, where we use the F to format it, right? So F is going to stand for formatting. Essentially, everything within these parentheses is going to be formatted. It's pretty much the exact same thing that you would use as your backticks, but instead of backticks, you put in the F prior to the string to let the console know that you are formatting the string that follows, right? So by adding the F behind the quotation marks, we can use the curly brackets to give it our variables. Notice that we're not adding the the dollar sign before our curly brackets, right? It's by itself. Because the F already lets it know, hey, I'm already formatting this, and it's just gonna use the curly brackets for it to tell apart what is a string and what is a variable, right? So you don't need to add any dollar signs here. It should just be something as simple as curly brackets, and it should replace for us the string. So let's go ahead and see that work. Let's put a space here, right? Here we had to manually add the empty space because we're join them together with a plus sign. But because everything between the quotation marks here is the string itself, this is going to be counted as an empty string on this little space right here, right? So we can go ahead and print that out, and we get the exact same result in two different manners. Everyone still with me? Any questions up to this point? Okay. Time is 7:21. Let's go ahead and take a 10-minute break before we even continue and talk more about Python. All right, so come back at 7:31. All right, let's go ahead and come back. We're gonna go ahead and continue with where we left off. Let me share my screen. All right, the next thing we're gonna talk about is casting to string and integer. All right, so we did it very similar to it earlier, from float to integer, integer to float. And we're gonna do that right now from string to integer. So we're gonna create a variable. So we call it num to string, and to typecast it is what it's called. Into a string, we're gonna use the str method, right? So str opening close parentheses, and anything that we wrap around these brackets or the parentheses is what we're going to convert into a string. So we can add the 45 in here, and this itself will let the console know, hey, this is supposed to be a string, right? And then we can do string to num. And to do that, we'll use the integer method like we used before. And then within here, we'll deliberately add a string, right? notice that it's in quotation marks, different from what line 1 was. And line 1, we didn't specify that it was a string. So the console will automatically think of it as an integer. But by adding the quotation marks on line 2, we're letting you know, hey, this is a string and you want to convert it into integer. All right. And then we can print out num to string as well as string to num and see how that prints out. We can't tell a difference specifically right here in our console. It both shows 45, 45. But what Python likes to do as well is print out the type of what we're working with. So we can do print, and then we'll call the type method within the print method. Inside this type method, we're going to do num to string. And we're going to replicate the same thing down here, but we'll do string to num. And we'll see that it'll print out the 45 and 45, right? Then we print out the type for each one of those. Notice that the first one is a string and the second one is an integer. So although they look very similar, their actual type is different, right? So, sometimes you might get an error saying like you can't do something because it's a string, and let's say you try to add two different numbers, but for some reason it was a string, and that's a good time to kind of check what is the type. And you can even use this in your if else statement. If whatever is a number, then add it. If not, then do something else with it, right? So you can use the type to check it. If type of num to string is equal a string, then concatenate. If or else the type is a number, then add it, right? So using the type is a great way to figure out what your variables are, to see if what you're working with is actually going to do what you want it to do. Booleans, right? True or false. There is a slight difference between JavaScript and Python, and that's how you type in false and true. We can create a variable called this is true and assign the true Boolean. You guys can use just typing in true like this, but notice Python is not going to recognize that. It's going to kind of try to autocorrect you to how it's supposed to be typed, and that's because the true and false statements in Python are supposed to be capitalized. All right, so this is false, and we want to capitalize the false. Once again, notice when we type it like we did in JavaScript, it wants to autocorrect you to capital letter, right? And then we can print out the type of these variables. So this is true. Print out the type again. This is false. And then in our console, we can print them out. And both of these are Booleans, but one's true, one is false. Once again, the capital letter is what separates this from JavaScript, right? Only real difference between JavaScript and Python is how you type a true and false statement. Cool. All right, basic arithmetic, right? And absolute. So for adding, just like JavaScript as well, we can call this my sum is equal to 3 plus 4. This will add on your console. For subtracting, we'll call this difference. We do 3 minus 4. That'll subtract 4 from the 3. And let's look at what result that gives us, right? Oh, print my sum, print difference. 3 plus 4 will give us 7. 3 minus 4, notice it gives us a -1, so it goes into negative, so it will do the arithmetic for you. This should be the same as JavaScript. For multiplication, we can do product is equal to 3 multiplied by 4, so 3 asterisk 4. Print that out. That should give us 12. Cool. For division, we'll just call it division, is equal to 3 divided by 4. print division, right? So 3 divided by 4 gives you 0.75. And then an absolute value, right? That's the next one. It's not, I wouldn't say that. Never mind. This is what I'll say. Absolute value will give you what the value is supposed to be, whether it's negative or positive. It will give you the absolute version of it. So if we say absolute value, that's what we'll call it. Use ABS. If you give it a negative number, it'll give you the positive version of it. Right? It will give you a 5. Not -5, a 5. Notice that if you perform simple division in Python, you will also get a float, right? What if this was 12 divided by 3? 4.0, right? One thing to consider. What if we do absolute value of division? 4.0, it does. Okay, so it doesn't change the float, but division will give you that float for you. I think it should be able to give you not a decimal to whatever division is, and it'll convert it to why is it giving me a 5? Is it because it was float? That's weird. Division 12 divided by 3. That's weird. Why does it give me, does it round up? That's some funkiness. For some reason, whenever you convert the 4.0 from the division into an integer, it gives you 5.
I think you're just not printing that decimal.
Yeah, I was about to say. We're printed out now decimal. You're right. I caught it right as you were saying. Where did I do it? In not a decimal. There we go. 4.0. That's weird. Yeah. I was like, that's kind of confusing. Why would Python do that? There's no way. Okay, so yeah, so we can convert it. So even though the division will give you a decimal, you can always convert it to an integer to give you exactly what you're looking for. Floor division and modulus, right? So what's cool, instead of using, I believe in, if I remember correctly, in JavaScript, we have to use the math, right? Math.floor. You don't have to do that here in Python. In Python, you can do, for example, floor 1 is equal to 7. Instead of doing 1 / you can use 2 /. Floor 2, we could do -7, floor 2, and print both of these out. Let's do it on the same one so I don't type. All right, so 7 divided by 2, it should give us 3.5, but notice that it gives us 3 instead, right? Because we use 2 /. So by using the 2, we're not just dividing, we are doing it to the floor. So it's bringing it down to its nearest value, which is 3. For the -4, if we would have just used division, we will get -3.5, but because we use the floor method, it gives us the 4, right? So notice because it's in a negative, right? It doesn't go to 3, it goes up to a 4, right? Because it goes lower. Does that make sense? The modulus operation, right? So the modulus operation done with the percent symbol gives you the remainder of division. All right, so the remainder. So if we were to do 10 modulus 5, what do you think that'll give you?
Zero.
0, right? 10 modulus 5 will give you 0 because there's nothing left over. Right, 0. But if we were to do 10 modulus 6, it should give us 4. Right, so 10 divided by 6, you know, if you guys go back to elementary, you know, 6 fifths, it's in 10, 6, one time with 4 being left over, so it'll give you the remainder of that. All right, so modulus is a great way to see how many times something fits into a number if you want to get the remainder of it. All these examples can be found in your slides. If you guys want to go back and make little flashcards of it, I encourage it. Exponents and concatenating lists, right? So exponents and concatenating lists. If we want to use to the power of 2, we would use, instead of just 1 asterisk, we would use 2 asterisks, and that'll give us to the power of 2, right? That's how we use an exponent in Python, right? So 3 to the power of 2 gives you 9. Now, for concatenating lists, we can do list 1 is equal to 1, 2, 3. List 2 is equal to 4, 5, 6. And then down here, we can print out list 1 plus list 2. And you will see that it's going to join them together, right? 1, 2, 3, 4, 5, 6. We just do conjoined list is equal to list 1 plus list 2. Call it concatenated list. All right, so if you wanted to join this, if you want to create a list that has multiple lists together, you can just join them like that using the plus sign. Cool. Another thing you can use is the plus equal sign to add things to it, right? So here we can say list 1 plus equals list 2. And what that does is it tells your console, hey, I want to grab whatever is in list 1, and then I want to add something to the current value. I don't want to change what list 1 has. I want to add something else to it, right? Keep it what it is, but add the next part, which is list 2. And we could say list 1, print that bad boy out, and it will give us the exact same input, right? So instead of doing something like this, where we can do number 1 is equal to 4, number 2 is equal to 6, we can say number, instead of saying like number 3 is equal to 4 plus 6, or number 1 plus number 2 to get 10, we can just say number 1 plus equals number 2. And it'll add this value into the current value of what number 1 is. Right? The plus equals allows us to remove that middleman that's right here, where we're doing like number 1 plus number 2. It's just a quick way of adding things to a total. Cool.
I didn't catch what happened though when you did plus equal to a list, to lists instead of numbers.
Yeah, so if we had let's go back. Right. You have list 1, list 2. You have 2 separate different lists. We create a new variable here called conjoin list. And then we can do list 1 plus list 2. If we print that out, what you're gonna see is that it's gonna join them together to make one big list. Right. So we see here one big list and conjoin list. It added both of them together. So even though they're 2 separate lists, they're here put together within one list.
All right, I thought you did like the plus equal on it. I guess you could.
We can.
I guess you can. Okay, yeah, that's
So
a nice feature to be able to do that.
yeah, we can
without
do list 1 plus equals list 2. It's gonna do the exact same thing that we saw with our addition. It just joined two lists together. Print that out again. We see here the exact same result that we did earlier. Cool.
Yep, I put print list 1 plus equal list 2. You can't, that's not the same thing though. You have to make it a,
I'm sorry, say that again.
never mind. I just did print list 1 plus equal list 2. It doesn't work that way though. I tried to do that instead of making a variable, but no.
Oh,
never
I see
mind.
what you mean. So if you try doing list 1 plus list 2, like
Yeah,
that,
and it didn't, no, plus equals.
plus equals. Oh yeah, it's not gonna do it just like that.
Okay.
Cool.
Yep, thank you.
Okay. Now you might have noticed I'm using a different terminology, right? I'm saying list instead of an array. In JavaScript, we use arrays, and the difference between the list and arrays, they're practically close to the same thing. The biggest difference is lists can store elements of different data types, right? So I can have a list 1 is equal to numbers. I can have decimals. I can have strings, right? And I can have booleans, right? These are all different types of data, and it's okay. I won't get an error, right? For arrays, they can only store elements of the same data type, right? So they all have to be either booleans, they would all have to be either integers, they would all have to be strings. The difference between the list and arrays, the main difference is the fact that lists can store elements of different data types, while arrays by nature can only store elements of the same data type, right? Lists are generally slower than arrays for numeric operations. Lists have more built-in methods like append.pop, stuff like that, right? But it doesn't really, it's not a big issue until you start working with other languages. Other languages are a little bit more strict of creating lists and arrays. In Python, we just call them lists. Just know that we can use different data types within that list, right? But they're kind of pretty much the exact same thing, right? And if you want to use specifically an array in what you call it in Python, I believe you have to like import it. It's like a module in itself. But you don't really see that often. I've never really had to use it. But in Python, we just call them lists. Cool. All right, so common Python error messages. All right, I'm going to go ahead and bring my slides back here. All right, so the error message that you most commonly see are these four. EOF being end of file, so you probably forgot a parentheses somewhere. A name error, you call something before assigning it, right? So it doesn't recognize what that variable is. So there's somewhere you didn't assign something properly. Syntax error, you want to check the spelling in your file. There's probably something wrong with your syntax. Type error, you're trying to perform some action on the wrong data type, or there's typically a typo, right? Now, the first practice we're going to do, right, is going to be your coins.py. So if you go to your lesson 07 on your repo and go to coins.py, you're going to find your README, right? The coins.py itself is empty. It's going to be up to you guys. But the README is going to tell you you have to write a program that asks the user for an integer number of cents, right? From 0 to 99. It outputs how many of each type of coin will represent the amount with the fewest total number of coins. When you run your program, it should match the following format. The console should prompt you for input, right? It's gonna ask you, please enter an amount in cents less than $1, right? Here we see it's 87. This is just an example, right? Don't try and just code this in here like this. The user gave it 87, and we see here what the response should be. Your change will be Q, I think quarters, right? It's 3 quarters, 1 dime, 0 nickels, and 2 pennies. Hence, you may find the modulus, the mod operator, useful, right? And you may not use any loops because we have not covered that yet. So don't start adding loops to it. Right? Quick reminder of how do we do this, right? So we can do something like amount is equal to input. Please enter an amount of coins. I don't know if this is exactly what it's asking. I don't remember. But this is how we're gonna receive our input from it, right? Oh, I'm in the wrong location. CD coins, Python coins.py. Right, please enter amount of coins, and I can give it like 45. That's all it does so far, right? But you might want to start off like this, grab the input from the user, and then kind of start doing some math in there to try to figure out. And then the actual message itself, this should be a formatted string that you guys are returning, where you are adding the values of whatever coins you figured out you have to use. Cool. Awesome. Let's give that about 15 minutes to do, and then we'll cover it afterwards. All right, we're gonna go ahead and move forward with this assignment. I'm gonna go ahead and share my screen. So you guys should be looking at my coins.py. It should be an empty file. There should be nothing in here. And we're gonna go ahead and code along to this assignment. So first and foremost, the file or the program should ask the user for some form of input and save it into a variable. We're gonna call it the variable cents. And then we're going to assign it an input, which is gonna be, please enter an amount in cents less than $1. All right, and then put colon space for some nice formatting. Now, just for redundancy and to ensure we get the right input from the user, what we're gonna do is we're gonna wrap all of this within our input tag or our input wrapper, right? That way, whatever is given to us from the user is immediately converted into an integer. And if it's not integer, there should be some kind of error because it's going to be the wrong information, right? And we can do more stuff about kind of catching errors and stuff, but that's out of the scope of this lesson. For now, just know that what I'm doing here is just ensuring that the user only gives us an integer. Now that we have the sense that the user gave us, we want to do some checks, right? We're not using for loops because we're not there yet, but we're going to use some an if statement, right? Which is fairly simple. We're going to do if 0 is less than equal to cents, right? And if cents is less than equal to 99, then we want to do something. Big difference here already when it comes to if else statements. Normally we do something like this. If 0 is less than equal, right? You wrap this bad boy in parentheses. You don't have to do that in Python. We can just go ahead and right off the bat start coding what we want to check. Right. So if 0 is less than equal to cents, and cents is less than equal to 99, then we want to do something. We're just verifying that the user did not give us more cents than we requested, and there's actually and not a value of 0, right? Because if it's a value of 0, then there's no point in checking how many quarters and dimes fits in that because it would be 0, right? So if it's doing this, then we want to do something else. I want to print out this is not a valid amount. All right, that's kind of how your if else statement looks like. I put pass because I don't have any code here. I just want to ignore what this does. And essentially what the pass is telling the CONT to do is once it gets to here, because there's no code here, it's just gonna get to pass, it's just gonna go to the else statement, right? Or it actually won't even run anything if I'm correct. Because it passes everything, right? So it gets to if statement. We passed in 54, so it meets this criteria. It gets to line 3, and we put pass. It pretty much says get out of this code block and skip everything else, right? But we never even got to the else statement because it met the criteria of the if statement, so therefore else never gets ran. Does that make sense? All right, because we didn't have to go to the else statement because we passed the if statement. But the if statement says pass, so therefore all this is pretty much useless, right? But now that I have my if else statement kind of coded out, I can kind of start adding some functionality in here. So if the sets are given to us actually meets the criteria of being greater than 0 and less than 99, then I want to do something. First and foremost, I'm going to check for quarters. So I'm going to create a variable called quarters. And then I'm going to divide our cents and to the floor by 25, right? So if it was 57, it's going to grab 57 divided by 25 and give me the answer. If I didn't add floor, it would give me some weird number, right? Which is not what we're looking for. And we can see that here by typing in 57, it gives us 2.28 because 25 does go into 57 twice. It gives us a 2, but then it doesn't fully fit the third time, right? It's a fraction of what's left. It's only 7, so it gives us a float. So we require that floor method. And by adding the floor method, we see here that we get 2. So we know that for sure we can give them a change of 2 quarters for the number that they give us. Now we have the quarters and we have to decrease our cents because we've already accounted for the quarters. We need to know what is left over so we can work with that. So what we're gonna do is we're get cents and we're gonna change what cents is. And if you guys recall, we did something very similar during the walkthrough. We did plus equals to kind of just change the value of cents right off the bat. We can do that with modulus as well. We can do modulus equals, right? We're gonna do modulus equals 25. And what that's gonna do is going to divide cents by 25, and it's gonna save the remainder into cents, right? So that should return to us 7, right? Let's print out cents and give it 57. We see here cents is 7, right? So whatever is left over from the modulus will be 7 and is assigned to cents. All right, cool. So we can move forward. We got the quarters. Next is going to be the dimes. So after that, we're going to do dimes is equal to cents modulus 10. And same concept. Whatever's left over, we're going to do cents modulus 10 to get rid of that. Modulus equals 10. And let's see that at work real quick. Let's do 98. And cents ends up being 3. Well, why? Well, because 98, so when it gets to quarters, it removes the quarters of it. So it gives us, it takes off 75 because it fits 3 quarters in there, right? But after that, we are left over with 23, right? So cents ends up having 23. When it gets here, 23 divided by 10 will give us 2, right? Because we did floor. And then we do the modulus 10 on the cents, which is end up giving us 3, right? The remainder of that. So that takes care of dimes. Next, we'll do nickels is equal to cents floor 5 to get the nickels. And then finally, we want to remove the nickels, but at this point, because it's less than 5, whatever is left over, we can just, it's gonna be pennies, right? So pennies is equal to cents modulus 5. Now we can print at the very end, print, we're gonna use the F so we can format our string. Your change will be, and then we can use quarters, add our quarters in here, our quarters variable. D for dimes, add dimes. And for nickels, add our nickels. And then P for pennies, and add pennies. All right. We can open this bad boy up, go to 98. And we see here your change will be 3 quarters, 2 dimes, 0 nickels, and 3 pennies. Awesome. Cool. That concludes your coins.py. Now let's go ahead and move forward. All right, so follow along exercises comparison operators. So a little backwards, but let's open up our file that we were working on, our Python code along. Let me go back in there. Okay, there we go. So comparison operators, the way that we compare things is, as you guys just saw, the greater or equal to, less than or equal to, or equal to, right? So we can create num1 is equal to 5, num2 is equal to 2, and we can say is num1, and we want to compare things, we'll use num1 equal to num2. Right, what this can do is can compare the values between num1 and num2, and it should return to us a true or false. So if we run our script, let's see, we should be able to do, there we go. By printing it out, we can see here, we print out num1 is equal to num2, we see false, right? By using the double equal sign, it compares the values of your variable to see if they're equal to each other. Obviously, they're not equal to each other, so we receive a false statement, right? Now, what if we do an exclamation mark, right? What the exclamation mark is going to do for you, it's going to check if it's not equal to the other variable. So we're going to print out num1 not equal to num2, and it should return to us a true statement. And we see that right here. That means it's true, right? These are not equal. We know that because the variable is 5 and 2. The next one we're going to talk about is going to be greater than. Fairly simple as well too. It should return to us a true statement because 5 is greater than 2. For the less than, it's going to be false. 5 is not less than 2. And then we have the example that we used earlier. 5, is it greater than or equal to 2? It's true. It is greater than or equal. Less than or equal? It's not, right? But what if we convert 2 to 5? It should return to us a true statement, right? Because sure, num1 is not less than 5, but it is equal to 5. So we do receive that that value. Now, what if we were to do absolutes, right? We can compare absolute. So we'll wrap this like that. We can do num1 minus num2, which will return to us 3. That is wrapped within the statement. Let's convert this. Let's do 2.0. I don't know if I'm doing this correctly. Less than 0.0001. False. Right. So obviously dividing 5 by 2.0 and then using the absolute method and comparing it to a decimal, it receives false, but we're able to compare different variables with floats, right? So in integers, floats, integers, even if we don't use that, we should be able to compare the same thing too, right? False. Moving on. Chaining comparison operators. So in JavaScript, when you have chained stuff together, you have done actually I'm talking out of scope. Never mind. So to chain operators together, you saw a representation of that earlier. If we were to do x is equal to 5, y is, we just keep the x. If we do 2 minus x, we can also do the n and say x less than 7. That would compare both of these together by using the n. You guys, I believe you guys use, is this the or how do you use the n? You guys use
And is 2
double
ampersands.
double ampersands, correct? Yeah. Sorry, I'm not that familiar with JavaScript. I don't use it too often, but you guys have been using the double ampersands, right? For the ands, for ors, you guys use the pipes. For here, it's more English. You all you have to do is use the and. All right, A and D. You don't need no ampersands. If you want to use the or method instead of using the pipes, you just use or, right? Isn't that nice? So a lot more English. You can also do what I did on mine, where you can just chain it just like this: 2 less than x and x less than 7. This will return to you the same thing as and. So 2 less than x and x less than 7. That is the exact same thing as doing this. Cool? Logical operators. You can do something like bool 1 is equal to true. Bool 2 is equal to false. And then to use both true and false, you can do bool 1 and bool 2. So you are able to use the and for compare booleans or chaining booleans together. You can use as well as or. So bool 1 or bool 2. So you can compare between one or the other, just like we did earlier with the variables. We can also check if something is not something, right? So you say not bool 1, right? Bool 1 is currently true. So if you want to check something, if it's not true, right, you would just use the not method. And the way that would work is if not bool, not bool, what am I doing? If okay, there we go. If bool 2. My bad. I had a freaking underscore there. It was I couldn't even see. I was like, what is going on? If not bool 2, print this is true, right? And that's how you would check by checking if something is true or false, right? Data flow and if statements. So here we go. Man, I really gotta change the flow of these slides. I do this every class. I'm like, oh, I gotta make these changes, and then the class ends, and then life happens. But yeah, I'll change this flow of the slides. So we're gonna create a variable here. We're gonna call it 12, and we're doing if else statement. If num modulus 2 is equal to 0, then I want to print num is even, right? Remember what the modulus does. It divides it. If it gives you 0, that means it was an even number and you were able to divide it by 2 effectively, right? So we check with an if statement, and then the else will be num is odd, right? And we can run that and we say num is even. So if else statements, before up to this point, you guys been doing something like this, where you put it in parentheses, open and close curly brackets, and then you would put what you want to do within those curly brackets. And then else right there, it can get very confusing like that, right? And then you have to do within this code block, you print what you wanted or console.log. No longer, right? For Python, you don't have to do any of that weird stuff. You don't need any parentheses, any curly brackets. You just straight ahead, go straight into your code, right? Very, very user friendly. I can't stress that enough. While loops. While loops, if we had a total score, create 0 here, we can say while total score is less than 100, I want to let's do this much simpler. While total score is less than 100, I want to print total score. And what's going to happen is it's going to get to line 2, right? Total score is currently set to 0. So it gets to line 2 and it's going to start this loop for us. Like, hey, is total score 0 or is it less than 100? Yes, it is. So I'm going to do something. I'm going to print total score. After that, I'm going to increase the total score by 1. Actually, let's do it much simpler. Let's increase it by 10. I don't want to get a bunch of stuff on my console, right? It's going to increase it by 10. Once it's done with this, it's going to go back up to line 2 because the while loop is still happening, right? We start this while loop, total score, we increase it by 10, but it's still not 100. So it's still going to stay here within this code block. Gets to total score. Hey, is total score less than 100? Yes, it is. It's only 10 right now. I'm going to print total score. And it's going to keep doing that until it's done, right? And we can see that here when I run it. The first time it goes, it's going to print out total score, which is 0 because it's not 100, and then increase it by 10. And every time it goes around in this little loop in the circle, it's going to be increasing by 10 until it gets to 100. Notice that it doesn't print out 100 because this only runs if it's less than 100. When it's 90, it's going to say, hey, is total score less than 100? It is because it's 90. I'm going to print 90 out. Then I'm going to increase it by 10. And going to go back to the while loop. Is total score less than 100? No, it's not. It's equal to 100. So therefore, this won't happen. This will just stop. It'll never print out 100 because it doesn't go into the code block. But if we change the less than to less than equal, we see here it does print out the 100 because it gets to the 100 part. It's going to check, hey, is total score less than or equal to 100? Yes, it is. It is equal to 100 right now. So it will go to the code block and it prints out that total score. Right? In your slides, you're going to see this, avoid infinite loops, right? While true, print high. Well, this is an infinite loop, and you guys are probably very familiar with this when you guys start coding. You guys, I'm pretty sure every single one of you guys in this call did it once, at least once, right? And you're like, what is going on? It's not stopping. That's because you never set a condition for your while loop to stop, right? You never change the value of true. You never change it to false. So it stays true. So therefore, it's going to go over and over again through these 2 lines, hoping for true to turn false, right? And it never did. It just prints out high, right? Over and over again. For loops. How do you know which of the for loops to use? All right, so we're going to talk about for loops now. There's 2 different for loops. We're going to create a variable here. We're going to call it word. And I don't know, such a difficult word that he created here. For example, we'll just say dictionary as our string. All right. The way to start a loop will be using the for method, very similar to how you guys did in JavaScript. right? But in JavaScript, you guys have something to do. You had to do something similar to this. For, and you did let I equal 0, right? While I is less than 10, I plus plus, yada yada, so on and so forth, right? No longer, right? You can loop directly what you want to do, right? You can even loop to strings. So what I'm going to do here is I'm going to do for I in word, right? What that's going to do is it's going to loop through the variable word. If it's a string, it'll loop through every single word in here. I'm sorry, every letter in here. And we can see that in real time. We can print I out. And we see the dictionary, every single letter gets printed out as its for loop runs. For I in word, I is just an imaginary number. It's going to represent the index of where we're working on. In this situation, it takes the word from the dictionary and we're printing out, I'm sorry, it takes the letter from the dictionary word and it prints out that letter, right? So I becomes the letter. It's going to go into word, right? It grabs the first letter. That's what I is. It prints out D, goes to I, C, T, so on and so forth until it prints out the entire thing, right? We weren't able to do that in JavaScript so easily. We had to do let I equal 0 while I is less than, the word dot length, right? Because we want to figure out how long this word is, right? I plus plus. And then you guys did console.log. You got the variable word, and then you put I in here to grab the index. It was way too long. You don't have to do that for JavaScript. I'm sorry, for Python. All you have to do is for I in word, or we can even say, we can change I to whatever we want. We can say for letter in word, print letter, right? It does the exact same thing. But we can still do it the way that JavaScript does it. And we can use it by using the range method. We can say for I in range, and we want to get it in the range of whatever the length of our word is, right? Range is going to allow you to choose a range of numbers from whatever to whatever, right? The range that I want to do it is in however long my dictionary is. Just like we did word.length as if we were doing JavaScript, you can do the exact same thing in Python, but instead of doing word.length, right, you do len, open and close parentheses, and you put the word in there, right? Len standing for length, right? And what this is going to do is going to grab the length of word, right? Whatever this is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's going to grab that. And we can even see that in real time, print I. 0, 1, 2, 3, 4, 5, 7, 8, 9, right? This becomes a number because we're using the range method, right? It grabs the length of whatever word is, and we use the length method. I believe we can even do, no, let's do what? Yeah, there we go. If we didn't like the index that we're using, which is started at 0, we can start the range at 1 and go up to whatever the length is for dictionary, right? Cool. Now, we can go back to what it was before. We can say for I a range of length of word, and then we can print out word and then I, right? Because we know I is supposed to be a number now. And this will give us the exact same thing as if we were using JavaScript, right? Where we go in there and grab every single letter in that index. So you have two different methods. You have this method to do the exact same thing that this would do for you. Right? These are the exact same thing. Print it out, we see here, they're together, back to back. This runs first and then gets this. It does the exact same thing, but we were able to write it differently. Right? The question is, how do you know which of the for loops to use?
I'm guessing it's like JavaScript where you know the amount already. Or if you don't know how many it's gonna go through, how many iterations?
See, I
Um,
think the second would give you more control, right?
yes, it'll give you more control because range. If you saw how I did earlier, I was able to put the start point, right? Range will give me more control of where I want to start looping from. Whereas for letter and word, it's gonna start from the very beginning, right? Range does give you a little bit more control. It depends what you're doing, and it's up to your own discretion of what you're trying to do, right? But two different ways of doing it, and they both give you the exact same outcome, essentially. Cool. When to
I had a
use
quick,
it? Yes, Justin.
I had a
ask
quick
away.
question in regards to this. So if you were to go into a loop, would you have to exit a loop using break like you would in JavaScript, or would it, like for instance, if you had like FL statements, would it keep like alerting all the way down through the process, or would you have to enter break in there? I can't remember if Python does that or not.
Yes, you can do that. So if you want to, uh,
Like a good example would be a switch statement where you had like 3 or 4 case statements. It would be like, and you had it alert on every different case. There are many possibilities where it would alert every instance of the else on the way down unless you ran a break. I know that from JavaScript. I was just trying to figure out if it did it in Python.
Typically, you're
Python,
gonna have a return statement.
yeah,
Well, yes, unless you're doing specific iteration, like, like string stuff, I guess, in particular.
You can call pass then.
Okay.
yeah, you have pass. Continue is another good one that you can use. If you reach to a point of what you're ready to get out of the loop, you can use return. That'll get you out of there. But yeah, you could actually use break too. You don't see it too often, but yeah, there are different ways of doing it.
So it's
Uh,
pass break, and then there's a third one. Can't remember.
Continue, I think is one of them.
Yeah, continue. Thank you.
Mhm.
I'll write that down.
Awesome. All right. So that takes care of the for loops. Actually, the next one was actually break and continue on your slides, right? So follow along exercises. So break and continue. We have the break, which exits a loop completely, right? Continue skips the specified iteration. And we see that here on the for num range. Actually, let's code it out so you guys can see it live. All right, so we have for num in range of 1 through 11. And then we can do if num is equal to 5, we want to break. And then print num. Watch what that does, and then we'll do, actually, let's do it now, right? So we run it. It gets for num a range of 1 through 11, so it starts at 1. It goes through it. Is it equal to 5? No, so we never get to the break. And we go to line 4 and we print out the number. But at one point, it does reach 5 and it goes into the code block for break and it stops entirely, right? And the for loop is complete, right? It never goes back to line 4 because it stopped the moment it reached to line 5, right? Now we could do for, actually, we can even, I'll show you pass here as well. We can use pass. And it doesn't do anything, right? Why? Because it gets to if num is equal to 5, then I don't want to do anything, just like we did earlier. And we print out the num anyways. Now let's see if we do continue. Continue will completely skip over your code block, right? It doesn't even go into 5 and it just goes into the next one. So it won't actually print out your num. It won't stop your for loop, but it'll get over it, right? And it'll continue with its operation. So different ways of doing it. It's up to you, right? Awesome. Nested loops. All loops can be nested.
Sorry, Roger. Can I just ask a question real quick?
Yes, you may, Gary.
Difference between pass and continue, is it just pass is more of like a placeholder?
Kinda, yeah. people tend to use paths more frequently when it comes to like, oh, you want to create a code block, but you don't want anything to happen just yet. You haven't given it a definition, or you're not exactly sure what you want to do there. Just kind of not get an error is it when we typically use paths.
Okay, just making sure. Thank you.
No problem. Next gonna be nested for loops, and this is where I'm gonna end the call afterwards when I'm done with nested for loops. So all loops can be nested, and data flow logic can be embedded within them as well, right? So we can create a list here. It's gonna be called animal list, and we'll add dog, cat, and bird. All right, we say for animal in animal list. What do you think it's gonna do? It's gonna print out every animal, right? We can say print animal. And it'll print out dog, cat, and bird. Now, for nested for loops, we can actually get even further. So when this for loop starts, it's gonna grab the first animal in this list and then it prints it out. After this loop is done, it goes back around, it prints out cat, and then bird until it reaches the end of the list. But what do we add a for loop within here? We can definitely do that. We can say for letter in animal, right? Once we start the initial for loop, we'll grab the first element within this list, right? And then it goes into line 4. It's going to grab every letter within that animal that we got, right? So this allowed us to grab the first item within that list, and then we can do something with it. We can even loop through that one, right? And we can say print letter. And you'll see here DOG, then CAT, BIRD, right? It starts with dog first, right? Line 3, we loop through, we grab the first item, which is dog. And then we go into a nested for loop. This for loop has to run all the way through before this one starts again, or until at least we were to put like break or whatever, right? But essentially, this is going to loop through and print out dog letter by letter before animal in animal list moves on, right? So we get into our initial for loop, we grab dog, we go into that nested for loop, which is looping through the letters in dog, and we have to print every single letter before this line 4 and 5 are done. Once we print out DOG, we finally leave the nested for loop and go back to the very top, and then it moves on to cat. Once it gets to cat, it goes back into the nested for loop again. It runs this for loop all the way through, prints out CAT. Once it reaches the end, this for loop is now complete. It goes back up to its top level in the circle, and it does bird. It does that over and over again until it reaches the end of the top level for loop that we have created. Therefore, printing out every single letter within every single animal. Cool. Any questions about this? My last class had a very tough time understanding nested for loops and how this is working. No questions? Okay, I'm gonna stop there. It is 8:51. I want to open up the floor for anybody that might have any questions about Python and anything that we covered before we talk about more stuff. That way you can also kind of take the time to soak in the information that we talked about right now. That way, it's not too much overloading you. But let me stop the recording.